Hi, welcome back. Hi, welcome back. What we'll be doing today is now optimizing the volume. So over here, we have the volume equation. So it's V equals to V1 plus V2, our rectangular prism volume, plus our open top triangular prism volume. I have the equation right over here. Now, so I'm going to break this up. So basically, you can see that your length and width are the same, which means that their optimized would be the same. So over here we have ratios. So we have all the ratios are based on the height of the prism. So S2 was our side for the open top triangular prism. H2 is the height for the triangular prism, and L1 is the length of the rectangular prism. L1 is also equivalent to width 1 because length and width are the same, and it's also equivalent to the open top triangular prism length because they're equal to each other. So whenever you see L1, whenever you see L1, you could sub that in for W1 or L2. So over here, I make L1 and W1 the same, so it becomes L1 squared times H1 plus 1 over 2 L1 squared times H2. That's the formula. Then I'm going to sub in our ratio values. So for L1, our ratio is CH1. I'm going to square it. And then it's multiplied by H1 and then plus 1 over 2. L1 squared, same thing, CH1 squared times H2. And at the end result, I get C squared H1 cubed plus 1 over 2 C squared H1 squared H2. Next, what I'm going to do is I'm going to use the surface area formula, and that's going to help us to optimize our volume. So over here, we know that surface area for, we're going to break it down actually. So surface area for a rectangular prism is 2 times width times length plus height times length plus height times width. So again, we make W L. And W times L is basically L times L. So it's 2 times L squared plus HL plus HL. So it's basically 2 times L squared plus 2HL. I sub in our ratios once again, and you can see that right over here. And once I expand, my whole entire equation comes out to be 2C squared H1 squared plus 4C H1 squared. Then I'm going to do the other surface here for the open top triangular prism. So the formula is length times H2 plus 2SL. I'm going to sub in our S ratio. As we know over here, our S ratio, so S, it's actually AH1. So what I'm going to do is, for that one, I'm going to sub in AH1. And for the rest of the L's, I'm going to sub in CH1. So I'm going to sub it in. And as a result, your final equation comes out to be CH1H2 plus 2ACH1 squared. Then I'm going to add both the surface areas together like how we did previously to calculate total surface area. And in the end, it comes out to be 2C squared H1 squared plus 4CH1 squared plus CH1H2 plus 2ACH1 squared. Now, as you can see, all of this is only one H2. So I'm going to isolate for H2, and that's going to help us find our optimized height for the open top triangular prism. When I isolate for H2, I bring everything to the other side. And then over here, you have CH1H2 by itself. So you're going to isolate for H2, you divide it, and this is what you have. Now, once you have found your surface area and you've isolated for H2, what you're going to do is you're going to set it equal to 0. Because it's a rational function, when you set it to equal to 0, that means only your numerator is equal to 0. So over here, you can see that your numerator is equal to 0. Now, what you're going to do is you're going to use your factoring method and factor it out whatever you can see. So when I factor it out, I get negative 2 out. So it's going to be surface area negative 2 times C squared H1 squared plus 2CH1 squared plus ACH1. And, yeah, that's basically what you're going to do. And then after it's negative 2 times, this is an, CH1 squared. So then it's negative 2 times C squared plus 2C plus AC, and I take the H1 squared outside. So these two are going to multiply by each other. So I bring surface area to the other side, and then afterwards I divide it by negative 2. So negative and negative cancel out. All you have remaining is C squared plus 2C plus AC multiplied by H1 squared. I divide it. I still have H1 squared. I square root it, positive and minus. And when I square root it, I have to sub in our ratio numbers and our surface area into the equation to get H1. This is actually going to give us our domain and our restrictions, essentially. So basically, right over here, you can see that I subbed in our values. So our surface area was this, and then I subbed in our C and A values, and that will equal to the positive or minus H1. So after subbing that in the end, it was 4.24. So it has to be, so basically it has to be greater or equal than 0, but smaller than or equal to 4.24. So now we're coming back to our volume equation. If you refer back at the beginning, we found our volume equation, and then we put it into terms of our ratios So remember this equation that we just had? H2 equals to this. Now, in our volume equation, we only dealt with one H2. What you're going to do is, you're going to do the same volume equation, but then instead of putting H2, you're going to sub in this. Now, that is why we found that, and that's also going to help us optimizing our volume. So we sub that in. When you sub it in, you notice that these two can be canceled out. That's great, because you get rid of your denominator. And in the final equation, you're going to have this right over here. So then you're going to try to bunch a whole couple of terms together to make it easier for you so you can solve for your H1. So, which will be your optimized H1, by the way. So what I found was, this is what I did, c squared minus 1 over 2 times c times 2c squared plus 4c plus 2ac all multiplied by h1 cubed plus 1 over 2c surface area times h1. That's a lot. You see, this is a lot. So I decided to make this all equivalent to z, okay? So it's going to be z, this, times h1 cubed plus 1 over 2 c surface area h1. See, it's right over there. Then I'm going to find the derivative of this. So bring the 3 down. 3z h1 squared. So you do 3 minus 1. So that's how you get squared. Plus 1 over 2 c surface area. h1, bring the 1 down. 1 minus 1 equals 0. So 1 to the power of 0 is just 1. Then I make this equivalent to 0. I bring the 3z to, I bring this to the other side. I then isolate for h1. Get that all over here. Then I plus minus square root it. And it's negative, so it's not possible. So what you're going to do is you're actually going to sub in your values. So you may be asking what your values are. So these are your values. Your negative c value. So you negative 1.658 times your surface area divided by 6 times z. Now you remember z was that whole entire equation. Remember this big jumbled thing? So over here you can see we did that. So this is our whole entire z equation. We're going to put in all our ratio number terms. And then we're going to find our final z value, which is this. You multiply it by 6. In the end, this is your square root. And it comes out to be h1 equals to 2.81 centimeters. That's your optimized h1. So in order for you to get your optimized volume, what you do is you just have back this equation that you had originally. Z h1 cubed plus 1 over 2 c times surface area h1. You plug in your z value. You plug in your height that you found. You plug in 1 over 2. Back again with your ratio. Your surface area, your ratio. In the end, V comes out to be 381.372 centimeters cubed. This in total is your optimized volume. Now, the last thing you're going to do after optimizing volume is you're going to find the optimized height for the open top triangular prism, which is our H2, which we already know. Remember I said this, we were going to come back to this. This is why we isolate for this and for other things, for optimization of the volume as well. Well, now we're back to this, and it's going to help us find our height of the side of the triangle, which I said we'll be using in the future. So you can see that the formula is right over here. Surface area minus 2c squared h1 squared minus 4c h1 squared minus 2ac h1 squared divided by ch1. So that's a lot. Okay, what we're going to do is we're going to sub in our ratio, our surface area, our new height that we just found, the optimized height that we found. So we know our surface area, we know our c value, which is our ratio, and we know our h1 now is the height that we just found, which is 2.81. You're going to put that all into the equation. In the end, h2 is going to equal to 29.305 centimeters. That is your optimized height. So this is all right. This is all for the optimization of the volume. Hope you enjoyed.